Hi guys, in this example what we're going to do is going to look at how to solve a log equation where we need to change the base. So the example I'm going to do today is log to base 4 of 3x plus 1 is equal to log to base 2 of x minus 1. Now, if you've seen the previous video on how to solve log equations, what you'll have noticed is I said that what I want is log a of something to be equal to log base a of something else on the other side as a single log here. So essentially what I need is these two log bases to be the same. Unfortunately, we can see here that this is log base 4 on the left, and we have log base 2 on the right, which means I can't equate the logs and therefore drop the logs. So I need to change one of these into the other's base. Generally what we do is we go for the lowest base, and here you can see we have log base 4, and here we have log base 2. So what I'm going to do is I'm going to change the left-hand side, this one here, into log base 2, as it's easier. So that means we're going to be using the change of base formula, which is number 5 here, rule number 5 on the right hand side. And we can see here it says log a, or log base a of something is equal to log base b of something over log base b over the previous base. And the b part is the bit that we get to choose. So what that means is I want log 4, so I'm just going to the right hand side and do it here. I want log 4 3x plus 1, and I want log 2. I want log base 2. So I'm choosing my b value here in the formula, the b value to be 2, and then I'm putting this on the top and this on the bottom. So let's do that now. Again, remember, I can choose whatever base I want using the change of base, and I've decided to use log base 2. So there's the log 4 again, 3x plus 1, and now I'm going to change it into log base 2. So log, I'm choosing the base 2, and then what we do now is we stick this on top. So that's 3x plus 1. And we're dividing it by log base 2 again. I've chosen base 2, so that's why the b is 2. And all we do now is we put the previous base, which is 4, on the bottom. That means now that we can simplify the bottom, because log base 2, 4, remember log is just exactly the same as asking, what index do I have to use in order to get from base 2 to 4? And if you're not entirely sure how we do that, we go log 2, 4 is equal to something, we're not sure. And that means we can say that 2 to the x, 2 to the something is equal to 4. 2 to the x is equal to 2 squared, and x is equal to 2. You probably would have got that in your head anyway. So that means we can now rewrite this as log 2, 3x plus 1 over 2. Okay, let's go back to the left-hand side and replace the log 4 3x plus 1 with our new expression. So now what we have is this has now changed, and we call it a half if we want, log, and we have base 2 3x plus 1, and that's equal to log 2 x minus 1 on the right hand side. Now I still don't have it exactly how I want it, because what I want log base a of something is equal to log base a of something on the right hand side here. And as you can see here, I have this half which is in the way, superfluous to what I want. So what I'm going to do is I'm going to multiply both sides by 2 in order to get rid of the half. And if I do that, I end up with this. So I end up with log to the base 2, 3x plus 1 on the left hand side is now equal to 2 log base 2 x minus 1. Now, that appears as if I haven't really done much, and in all essence, I haven't. All I've done is I've taken the half here, multiplied by 2 to get 2 over on this side. But what it does mean now is I can use one of my log laws, and the log law I'm going to use is log law 3 on the side here. And I'm going to use it backwards. So you can see I basically have 2 log 2 something, and I'm going to throw it up to make it into a power. So what's going to happen is I'm going to throw this up to there, and it's now become equal to a power. So I've got log 2 3x plus 1 is equal to, and now what we have is log 2, and it's x minus 1 all squared. Now, we're nearly there now. We have, of the form that I need, I have log 2 on the left-hand side of something is equal to log 2 on the right-hand side of something, which now means I can drop the logs. So essentially, what I have now is 3x plus 1 is equal to x minus 1 all squared. The logs have gone, and now it looks like I'm left with just a simple quadratic to solve. So let's solve this quadratic. I'm going to multiply out the brackets, and if we multiply out the brackets here, we're going to get x squared minus 2x plus 1 is equal to, on the left-hand side, still 3x plus 1. It's a quadratic, so I need to get everything onto one side. The x squares are on the right-hand side, so we'll go to the right-hand side here. So I've got x squared minus 2x minus another 3x is minus 5x. And as you can see here, 1 take away 1 is going to be equal to 0. So what we end up with is x squared minus 5x is equal to 0. Now I need to factorize this, so I need to take out a common factor in x squared and minus 5x. And that means I can take out an x, leaving x minus 5 in my bracket. And again, that's still equal to 0. So just to remind you there what we've done, x by x here will give me x squared. X by minus 5 will give me the minus 5x here. So I've just factorized this expression here. That means I'm going to get 2 solutions, or 2 possible solutions, I should say. And the 2 possible solutions are x is equal to 0 or x minus 5 is equal to 0. So x minus 5 is equal to 0 implies that x is equal to 5. And now what we'd have to do is we have to check both solutions because this is a log equation. So what we have to do is we have to check both solutions into our original formula, or original equation, I should say, at the top here. So the first one we're going to put through is x is equal to 0. If I put x equal to 0 in here, I get log 4 of 1 is equal to log base 2 of 0 minus 1, which is minus 1. I am not allowed to have a negative log. It does not exist. Therefore, x is equal to 0 does not work, and I cannot have that as a solution. Just double check x is equal to 5, so let's put it again up into the top equation up here. So 3 times 5 is 15, 15 plus 1 is 16. Okay, that's positive. And the second one, x, so that's 5 minus 1 is 4. Again, that bracket is positive, and that means x is equal to 5. It's a solution that we can use.